Alright, good morning. Today we're going to be talking about section 5.9, and it is going to be focusing on proportions. Alright, so the question that we're going to be starting off our proportion discussion with is Steve has a flag, an American flag, and it is 4 feet by 6 feet. And he's kind of wondering if there's like one of those huge parades or on a football field where you can make like a giant flag. That's a terrible flag. And he knows that the length of the flag has to be 120 feet. Then what would the width of this flag have to be? And we can use proportions to solve this, okay? So a proportion is made up of two equivalent ratios. And recall that a ratio typically looks like this. It can be like 1 to 2, or 1 to 2, or 1 to 2. And I prefer this fraction method the most because it's the most mathematical, and once we put it in this fraction method, we can use a lot of other strategies that we've already learned on how to manipulate it. So if we have a proportion, it comes up with two ratios. So we might say 1 to 2 is 8 to 16. And I can tell that they are equivalent, just like how they're equivalent fractions. I can multiply both of these by 8, and I can see that indeed this is a true proportion. If these aren't equivalent, I can't have a proportion. So this would not be a proportion. If I write something like this, 1 to 2 equals 6 to 13. This is not true, and this would not be a proportion. All right. When we are solving these proportions, or we're going to figure something out, we're going to use something called proportional reasoning. Now, typically we're not going to get a proportion that looks like this, 1 over 2 equals 8 over 16, because that's obvious. There's no work for us to do, there's no problem. What typically happens is that one of these numbers is an unknown, just like our American flag problem right here. I could indeed write this out as a proportion, because I know that American flags always have the same proportions, just like a sheet of paper. As the flag, so if I have my huge flag on a football field, I could also draw my tiny little flag right here, but I know that the lengths stay true. All that's happening is I multiply and drag out the entire shape. So I can say, as long as I line these up correctly, that my length is 120 feet, this flag is 4 feet by 6 feet. If it's smaller, it would have the 4 feet by 6 feet, because I know that it's longer than it is tall. So I can say this 4 to 6, and I can say that because it's a ratio, is equal to x to 120. Right? So now the question is, let me bring my little flag down here, and I'm going to use my proportional reasoning. 4 to 6 equals x to 120. And I can do exactly what I was doing before here to help me solve this problem. The question is, what do I need to multiply this to turn it into the same proportion? Well, 6 and 120, that should jump out to me because I know that 6 and 12 are factors and it's easy for me to get to those. So my mind immediately thinks, I bet 6 times 2 is 12, and to get that 0 in the end would be another 0. So I bet 6 times 20 is 120, and I can check. Oops. 6 times 120 6 times 0, 12 times... I wrote this wrong. Out of practice from winter break, sorry. 120 times 6. There we go. 0, 12, 2. Hang on. Now I'm just confusing myself. I'm not doing 6 times 120. I'm supposed to be doing 6 times 20. Wow. So 6 times 20. Much better. That was correct, but it was not what I was trying to do. 6 times 0 is 0. 6 times 2 is 12. Got it. Perfect. Which also means I need 4 times 20. And 4 times 20 is... Well, if I want to use my math skills, all I can do is get rid of that 0, cover it up. 4 times 2 is 8. Add it back in. And I can say that 80 over 120 is equal to x over 120. And now that I have both of the denominators the same, I know that the numerators also have to be the same because they're equal. So I can say that 80 equals x. So my flag here is going to be 80 feet tall. Sorry about my confusing little numbers over here, but this is how we do proportional reasoning. I'm going to do a couple more examples because I hope that I didn't confuse everyone by doing that. Let's take a look at this one. Example 2. All right, this one, instead of taking our flag and putting it into numbers, we're just going to start with some numbers. And we're going to be given 2 proportions, which means that they are equal. 15/35 is equal to x over 7. Okay, so now I can see that I have x over 7, and I need to make both of these denominators the same. So there's a couple ways that I can do this. I could make this number larger here, or I can make this one smaller, because this one seems pretty obvious that I need to simplify this down. Because when I see this 35 and the 7, that makes me think, I bet that I can divide those by 5 and turn this 35 into a 7. So 15 divided by 5, I know is going to be 3. 35 divided by 5 is 7, which gives me x over 7. So in this case, I can see that my x is going to be, let me make sure that I'm doing this right, x is going to be 3. Now, that begs the question, what would have happened if I would have just multiplied instead? Well, the problem with that is then I have to multiply my x, so it wouldn't work out as well, but it would give me the correct answer in the end. Let's take a quick look at what would have happened. If I had 15 over 35 equals x over 7, well, I know that to get from 7 to 35, I need to multiply by 5, which I can do to the numerator and the denominator if I choose to. This would give me 15 over 35 is equal to 5x over 35. All right? So then this would just tell me that my numerators are equal. So I have 15 equals 5x. Well, then I have to simplify again. Remember that I can solve this by dividing both sides by 5. So now I would have to say 15 divided by 5 is 3. 5 divided by 5 is 1. X equals 3. So in this case, it was definitely simpler for me to simplify first. And that's generally true. If I find something to divide and make smaller, it's much easier if I do that before I multiply and end up with a giant number later. Either way, I got to the same answer, so it doesn't matter especially, but like I've said many times, I'm lazy and I like to find the simplest way that I can possibly do these. Let's talk about example 3. If you feel like you know what I'm doing, then you can go ahead and go on to the homework, but I'm going to do 2 more probably. 32/36 is equal to x over 9. So in this case, I'm going to start with my denominators, and I'm going to definitely see that there is a relationship between 36 and 9. I'm going to divide this by, let's see, I'm going to divide it by 4. If I do that to one side, I have to do it to both. 36 divided by 4 is definitely 9. 32 divided by 4 would be, 32 divided by 2 is 16. Divided by 2 is 8, which would give me 8/9 equals x over 9, which I can then get rid of my denominators because I know that my numerators have to be equal because it's a proportion. So I can say that 8 equals x. Or x equals 8, doesn't matter. I could, of course, go the other way and multiply these, but then I would have the same problem that I had earlier and that I would need to simplify a bunch later. Let me check the homework and make sure that there's not any that I need to solve. Sometimes you may need to decide whether a proportion is true or not. Recall that a proportion needs to be equal. So I would say proportion, yes or no. And it'd be easy for me to check. If I say I have 3/4 equal to, let's see, 30 45ths, well, the question that I need to ask myself is, are these two equivalent? Well, I can see that 3 and 30 is an easy times 10. So if I multiply top and bottom by 10, it's going to give me 30 40ths. That certainly is not equivalent. If I can get my top or the bottom to match, and they both don't match, that is not a proportion. The answer would be no. You will have to do some of those, and I hope that makes sense, and good luck.